We got a little start on, and we're going to finish her off today. So let's see, where did we get to last time? We're looking at all the stuff that the local government buys. So education, police, all the stuff that's real local within the city is generally generated from property taxes and private funds. And so we looked at how cities might be able to take advantage of economies of scale by combining forces with other cities, diversity, demand, and some of that other breakdown. So today we are going to look at kind of the details of the model. So for a public good, we had non-rival and non-excludable. So non-rival meaning multiple people can enjoy the good at the same time. One person's consumption doesn't detract from another person's consumption or the benefits they get from consumption. And then non-excludable, meaning it's hard to keep people from paying for it. And so a lot of the goods that we have provided by government are not necessarily public goods in terms of economics. Probably the classic one we just talked about was roads. Is it possible to exclude people from roads? Chat box me up here. Is it possible to exclude people from using roads? And more specifically, exclude people who don't pay for them? Yes, tolls, right? So especially with today's technology and tracking, we could have you pay for whatever road you do if we had some sort of GPS system to collect taxes off the roads that you use. So it's kind of a rare thing. We end up having government buy goods or provide goods to us possibly for other reasons than these two features, but these are possibilities that make it hard for a market to work properly. And excludability is the number one thing, because a private business who's wanting to make a profit has to be able to exclude some people who don't pay from getting the good. And then so the local public good adds on, we're dealing with people in a small geographic area. So those are, we're kind of isolating the benefits to a smaller area. Okay, so here is our standard picture that you might recall from principles class. It's a little bit weird, but remember we do the vertical sum of the individual benefits to calculate the social benefit. So here we've got Lois, Marion, and Hiram. There's the words that the book uses. And so at 6 acres of park, Lois gets 20 units of satisfaction or is willing to pay $20. You know, if we start measuring the benefits in terms of dollars over here. For 6 acres of park, Miriam was willing to pay 28. And then Hiram is our park lover. He gets a lot of benefit, $48 worth of benefit from the park. So one single 6 acre park, in terms of a local public good, gives the people $96 of benefit collectively. How did we get that? It's just 20 plus 28 plus 48, right? So the terminology we used in previous classes, in principles class, is that it's the vertical sum of the benefits. For private goods, it's just the opposite. If you remember, if the price of a cheeseburger or the price of a, I guess it's a steak dinner is $20, then Lois would buy 6 steak dinners, Miriam's gonna buy 12, and Hiram's going to buy, I don't know, 26. And so the market demand curve is the horizontal sum. At $20, how many do people want to buy? 26 plus 12 is 38, plus 6 is 44. So 44 is the market demand curve for steak dinners. And so that is how we calculate the demand for a private good, the market demand, right? So you can kind of think about it being the market demand curve is the horizontal sum when we're talking about private goods, because if Miriam eats the steak dinner, the other two can't. They're not sharing it. It's not non-rival. Private goods are rival in consumption. And so for non-rival goods, we get the stacking thing going, and that's where this vertical sum part comes in. All right, does anybody have any questions, comments? Let me do a 5-second pause. Okay, so the rub's going to come in is that the market may not get the most efficient outcome for society. So the efficient outcome for the amount of parks would be where the marginal social cost of providing the parks, here it's each acre of park is has a constant cost to it of 60. So each acre is $60. And so the social cost of, if we have a 16-acre park, would be 16 times 60. And then we'd have to try to get that. No individual is willing to pay that much. So nobody's willing to, everybody's marginal benefit is less. Look, even Hiram here gets $38 worth of benefit. So if the 16-acre park is going to cost 16 times 60, then nobody's going to want to do it. So, but collectively it's possible. So if we have a 16-acre park and we've got 6 plus 16, the benefits equal the cost. So the marginal social benefit curve equals the marginal cost curve here at that 60. So 16, your textbook uses kind of RE. R superscript E is the efficient level of parks. So then the question is, how do we pay for it? We'd have to use some sort of taxes to figure out how we're going to pay for the park. So if we have that park system and it's running the $60, how are we going to pay for it? And so the answer is going to be with taxes. And one of the taxes is just a per person tax, or what the author calls a head tax. So one way to pay for the park is if each person paid $20 per acre. So if the tax per person per acre was $20, then that would fund the $60 park, right? So we have 3 people and 3 times 20 is 60. So a tax of that, so that's again called the head tax. So now we start to see the dilemma of paying it, because let me go to the chat box now to see if you guys are tracking with this. Is Lois in favor of a 16-acre park? Is Lois in favor of a 16-acre park? So 16-acre park is the society's optimal level of park, but Lois is not in favor of it, right? Because at 16 acres, the benefit Lois got of the last acre was down here. But now she's going to be hit with a tax of $20. So she's like, "Oh, that sucks. That's a waste of money. I'm not getting enough benefit out of the park." And would Hiram like it? Chat box. Would Hiram be in favor? He's our middle guy here, MBH. Would Hiram like 16 acres of park if he was going to be hit with a $20 tax? So look at that graph. It's kind of the same thing we did. Eddie's saying yes. I don't know if Daniel, if that was your old one. Oh, I guess it is your new one. Yeah. So let's see. Hiram. So at Hiram's, his marginal benefit is up here. which is greater than 20, so he'd be in favor of it. Miriam would not, right? So each individual person can be analyzed to say whether they think this $20 tax sucks or if it's something that they think is a good deal. Hiram thinks it's a good deal, the rest of them don't. And so that is one of the struggles now as we start to move into getting this park approved with local public dollars. If we have a vote of majority rule for the 16-acre park, are we going to have a park in our 3-person world? If we have a majority rule vote, yeah, we're not going to get it, says Eddie, right? So the vote's going to be turned down 2-1. So 2 versus 1. Hiram loves it. He's the one, but these two are saying that sucks. I'm not paying that much, right? And so the 16-acre park would be voted down. Yes.
Could you explain why the 2 aren't good for it? I understand why the 1 is, but why isn't the other 2?
So at the level of, let me clear off what I got here. At the level of 16, which was the efficient level for society, where the marginal social cost equals the marginal social benefit, right? Which is, they've got it up here labeled where we're adding together. So 16 is the efficient level, but if we put it to a vote, the benefit for Lois is up to her benefit curve, hang a left, it's less than 20. Because with the vote, it's a $20 tax and a 16-acre park. Remember, those two things would be bundled together. And for Miriam, her benefit is less than the $20 park. So they're both going to say no way. Okay, any other questions there? All right. So what if Miriam's demand decreases? Will that change anything? So if Miriam's demand decreases, it's not going to change anything with the vote, right? Because Miriam's our middle person, So a decrease in demand isn't going to do anything in terms of changing our median voter. They'd both prefer less. But if it was an increase in demand, if Miriam, let me go to a different color, if Miriam went up to here, so if this is MBM2, right? Now all of a sudden, Miriam's getting a good deal out of it. Whoops, sorry, didn't mean to do that. Okay, so this will kind of come back to us here on the next one too. So if the city holds a series of pairwise elections, so 12 acres versus 6 acres, what about 22 acres? You know, what should we vote for? So if we think about the pairwise comparisons on different levels, we could do all, you know, infinite number of sizes, but these are kind of appropriately chosen here. So first of all, let's have a vote with 6 acres. Well, 6 acres was great for Lois, and so she would be in favor of that. What about 12 acres? Marion and Hiram would be voting for 12 acres, so that would work out good. What about 22 acres? Well, the only person that would want the 22 level would be Hiram. So if we start to look at the spectrum here of running from 6 to 12, who's the deciding vote? Marion is, yeah. So that's our median voter, right? We only have 3 people. So the median voter is Marion. And so Marion is going to be driving the ship in terms of majority rule. So this is our median voter theory coming out, that the median voter is going to be the person who decides what size park we have. All right, let me pause there for questions. All right, so what we just went over was a head tax. So each individual would pay it's a per person tax, kind of a, it could be called kind of a flat tax too. But so that's not the way most cities do it. Ideally, in theory, we'd have a benefit tax. And so if everybody would pay a tax equal to their benefit, then we would get the efficient outcome. So with a benefit taxation, let me go back to this screen. Everybody would pay. So in this case, the 16-acre park, we'd have Lois paying this amount of tax, whatever that number is. And Miriam would pay this amount. And Hiram would pay this amount. Those three amounts, by the way this thing is constructed, is equal to their benefit, right? And so it would work. If we could somehow charge each person their benefit that they're getting from a park, then in theory, we could have the optimal solution, the optimal program. Now, are people, let me go to the chat box, are people willing to reveal their maximum willingness to pay? No. So this brings up the free rider problem of public goods, is that nobody has individual incentive to try to do it. It's better for them to get a free ride off of somebody else. And so basically, if the park goes through, Hiram was our person willing to pay the highest, but he only had to pay tax of 20. So he's able to free ride off of other people's tax dollars. And so that's why the some sort of voluntary system breaks down. It's really highlighting the market failure that can happen with public goods. But this can be used as an instrument to possibly draft some policy. So who generally would be willing to pay more for parks? Let me go to the chat board. High income people or low income people? Who would be willing to pay for more park space, right? It's kind of a luxury good, right? It's like, oh, I love the wilderness and it's so nice to breathe fresh air and whatever. Are people who are scrambling paycheck to paycheck to try to put food on the table and diaper on the baby aren't going to be as concerned about the park space. So now, who has the bigger house? So these are real simple questions, so just be ready on your chat box. Who has the bigger house, the high income people or the low income people? High. Who has the higher valued house, a bigger house? Who has the higher valued house? The high income people. So now if we start to have property taxes based off of the property you own, then we will be doing some degree of benefit taxation, right? So if you live in a $200,000 house and tax rates are 1%, you're going to pay $2,000 worth of tax. If you live in a $100,000 house, you're going to pay $1,000 worth of tax. And so now we've got this notion of, at least to some degree, chipping away that the high value people reflected in their property that they own are going to be proportionately paying more for the property or for the parks and the open space. So that is the idea of benefit taxation. Any questions? Let me do a 5-second pause. Okay. Oops. So this is just a picture of that benefit taxation. It was done by an economist named Lindahl. And it really is just showing the optima again, so we can kind of skip that. The Tiebout model is this idea that we've talked about before in terms of having a large number of municipalities, of cities with different laws and the ability to tax their people differently and have different levels of education, different levels of park, would allow people to vote with their feet. And so here's the kind of basic assumptions of the model. Is my bird bothering you guys, by the way? I can, let me go get that stupid thing out.
I was wondering what the hell that was.
Yeah, I thought we were in word science for a second here.
Yes. You guys
That's
are
true.
used to it with Oliver. All right. Hopefully it won't rain on him. I just threw him outside again.
What kind of bird is it?
Oh, it's a cockatiel. Usually he's pretty quiet. I don't know. He's been hormonal or something here lately that he's been chirping. Other classes I've had him in here and he hasn't been chirping as much. But okay, so interjurisdictional spillovers. What the heck was that? We did talk about it a little bit last time, I think. Interjurisdictional spillovers.
Was that the example from Kansas City, Missouri, and Kansas City, Kansas that you give us?
Yeah, so the other word for spillovers would be externalities. So usually those are couched as benefits. The spillover effects are usually external benefits or positive externalities. But across city lines, yeah, if there's spillover effects, that would distort this. And so this is saying no interjurisdictional spillovers. So anyway, in a perfect world, if you could somehow have that setup, then if you like the city with, low tax, medium tax, high tax, but they have high levels of parks and nice open space, then you just have people going from one place to the other, whatever city they like the best, they're going to vote with their feet. And so that was just some of the logic about having power pushed down to the lowest levels rather than a one-size-fits-all type of approach. Okay, so there's the list. I guess I should have did that while I took out the bird. You guys could have did a little reading. You can just kind of look at that briefly. Perfect information. These are just all kind of standard like assumptions that could move out. And all they're saying is that if we had this setup, then we'd have an efficient outcome in terms of people locating to the right place. We'd get efficiency through voting with their feet. Okay, so median voter. Does the election format matter? So how do we get things done? So this is kind of fun. So here's a city, and we've got big budget buck and penny pinching penny, and they're proposing city governments. Remember, this is the level of spending that each city is going to do. So we're going to have fancy education and lots of more money on police or whatever the case is. So we've got a $3 budget for Penny and a $9 budget from Buck. And these are our two elected officials. So when we go to vote, what this is showing is that the people of the town, 7, 8, 9, 10, this shows their preferences on preferred budgets. So there's a whole spectrum of people with how they'd like to see money spent. And so what is going to be the outcome of these two people electing for a possible $3 budget and a $9 budget? If we go back to our median voter, we're going to have a tie. So 55 people to 55 people. The 55, by the way, I guess it didn't show it in this example, is there's 5 groups or 10 groups of people in each one. So we got 11 types of voters within each one of these blocks. And so the median voter is going to split right down the middle, 55 to 55. There's going to be 110 voters total, and that's going to be a split. So the question is that a Nash equilibrium for penny and buck? So now put your politician hat on. There's a split vote. Would either one of those two like to make a move? Would either one of those two like to make a move? And if so, give me maybe in the chat box, there's lots of different answers to this, but make a single move for penny or buck that would make them better off. So we got Penny, remember, pitched the $3 budget. Let me change colors here. Penny pitched the $3 budget. She's the politician Penny. Big buck politician pitched 9. The vote ended up being split 55-55. So does either politician have a chance to do a move, taking as given what the other one has done to make themselves better off? And if so, tell me what in the chat box would be one of those moves. Okay, so Penny would say 6 to gain more people, right? Or Buck could go to 8, right? So look at how we're changing the median if we just have Buck move this way or Penny move this way. So as soon as you do that, now all of a sudden you're changing the median voter. So if Penny goes to 4, let's say, now she's going to pick up, these people are now closer to 4 than to Buck. That's the whole idea of changing. So these people are saying, oh, that's closer to my preferences. 4 is closer to my preferences, so screw Buck. I'm going to go with Penny, and Penny wins the election. So that's the concept here of what's going on in terms of the political realm, in a sense. And so panel 2 shows Penny changing to 6. So once Penny goes to 6, and you know, this is I can't remember if there's a question like this in your homework, there might be, but we can now calculate what the new median would be and how many voters. So now look at the median is right here. As you guys start to get a little bit more comfortable with this, the author is putting the median right here. Penny moves to 6, and so all we care about is who's between Penny and Buck. And so their preferences are now here. So Penny just picked up these people, and she's of course got all these people. These are all the low penny pinchers. So she's still got those guys, and now Penny's gonna win 70-40. So then is that a Nash equilibrium? Yes or no on the chat box. Is that a Nash equilibrium? It is not. So now we've got Penny and Buck moving to the middle. So if you've heard of, this is changing now in today's political environment because we're becoming more polarized. You guys have heard that. Maybe you haven't even given it 2 seconds of thought of what the polarization of, you know, the Democrats and the Republicans. We've got people on the extremes and we're becoming more separated, blah, blah, blah. Well, that's because historically, if they're playing to this, using the median voter theory, then both parties, the Democrats aren't going to be way to the left or way to the right in terms of the Republicans, because they're all going to be playing to the median voter. If they get the median voter, whoever that is, they win the election. So over the years, historically, Democrats and Republicans have kind of been right in the center, and there wasn't always a lot of difference between them. There might be some little differences here and there, but not a lot. Okay, let me do a 10-second pause for questions. All right. So, no reason to expect socially efficient outcome, especially once we bring the median voter. I mean, we're really coming down to one person that we're trying to please. And so we can look at elasticities here for the demand for public goods. So some previous studies, income elasticity on total expenditures, on education, on parks. So let's see, who's going to give me an interpretation of this number? So we have an income elasticity of 0.85. So let's see, who did I hear from? Daniel, give me a number between 3 and 7.
6.
6. 1, 2, 3, 4, 5, 6. Nate Hamilton's our lucky winner today. So give me an interpretation, Nate, of 0.85 income elasticity. And that's on education.
I mean, the more education you have, the more income you have.
No. Let's see. 1, 2, 3, 4, 5. Liz, what do you think?
I have no clue.
No clue. All right, let me help you out here. Let's just see if I can nurse you along here. So the income elasticity is the percentage change in quantity from a percentage change in income. And so if the income elasticity here is 0.85, we have that little trick that I've been working on with everybody over the time on what can you do with any number to turn it into a fraction. So Liz, I'm still on you. Any number to turn it into a fraction, what can I do to make this number a fraction?
Over 1.
Over 1, great. So now once you have it over 1, you can just make this connection. Let me change color here. So this sucker goes with this sucker, and this sucker goes with this sucker. And so are you able to pull it off now in terms of the relationship between income and education? The quantity here, by the way, is the education is what's on top here. I'll help you out. A 1%. That's the start. A 1%. I'm starting down here. A 1% change.
Russ, I think you froze.
He's gone.
Dang. Dang.
I did lose everybody. I was like, what happened here? Did I lose Liz? All right, so let's try that again here. Okay, so I'm hanging in the balance now. Did Liz get it right? Did you do it?
No.
Okay. All right. So now I lost my chat board here. So what is the thing here? We're going to have 0.85. So I don't know where I lost you even. So, but everybody, there's other people who don't know what's going on here. That's why I'm milking this one out, because you guys all need to know this.
Is it a 1% increase in income leads to a 0.85% increase in education?
Okay, good. Yeah, it looked like somebody had it on the chat box too. So Liz, on this, since we have percentage change in quantity of education over the percentage change in income is our income elasticity. Any number can be put over 1, put a little percent sign, and now you just tell the story. A 1% increase in income leads to a 0.85% increase in education. Make sense? Liz, give me a thumbs up or verbal, or did I lose my internet again?
Yes.
I was just confused at the beginning is why the
Looks
education is the
okay,
quantity.
good. My internet must be, yeah, my internet's sketchy. Okay. Apparently my internet's
I love how he was trying to tell us that his internet's bad and he cut out mid-sentence.
okay. maybe we're back, maybe we're not, but I'm going to switch to my other internet here if my cable is freaking out on me. So, all right, sorry about that, folks. So let's see, once I get, I'm going to go ahead and switch my internet. See if that helps. Okay, I think my system's back on my other internet now, so let's see what happens here. Give me a thumbs up. Are you guys able to hear me okay? I just switched to my other internet. Okay, thumbs up, good. Samir, thumbs up. Okay, I thought you were going down with that one for a sec, Samir, so I'm glad to see that. All right, so let's go back to the screen share and wrap this thing up. We're almost done, by the way. Okay. So here's the problems with the median voter theory. So it's more complex than just a single issue. There's lots of issues going on, and so the complexity of it is different than just the median voter. Conceptually, I think it does help out and does explain why we've seen a lot of policies move to the center so that they're playing to the most people. But not having just a single issue is a big part of it. And then other people, we do need everyone voting. And if people are abstaining, if only the radicals come to the poll, then the median voter theory is out the window, right? So those are kind of some of the quick issues that median voter theory would have. All right, so questions there. So I want to try to tackle a problem. It's that hopefully will kind of wrap things up for us here. We'll see how much time we have to tackle it all. It's a pretty good sized problem. And it's, if you guys have your version of it, it's chapter 20, number 4. So we've got chapter 20, number 4. We got some fireworks. And here it is.
Is it the apply or review?
The problems. I always get those apply. So number 4 of the apply. I'm going to screen share it with you here in a sec. All right. So the city of Rocketville, so if you want to take some notes down on a side piece of paper, or you can, do whatever works for you if you got some other digital techniques, but you got 9 people with incomes ranging from $1 to $9. 1 citizen at each one of those dollar values. So you got 9 people. And then we've got the marginal private benefits. So each person has a benefit of rockets for fireworks of this equation, W minus 1/9 of R, where W is the income for the person. All right, R is the number of rockets. The marginal cost of rockets is 18. And we're going to finance these rockets with the head tax. So we've got the per person tax, and it's per tax per person. So illustrate the efficient outcome, RE, for this problem. All right, so now that you guys got some of those details, the other thing here is going to be what's going to happen with majority rule. So I'm going to attempt this on the whiteboard, and we'll see how this rolls. So let me do a new share with the whiteboard. Okay, so I would encourage you to kind of draw this on your own paper as you go. So in the problem, we've got the 9 citizens with income of 1 through 9, and then each one's marginal benefit curve. I'm going to try to do this in 2 panels. So marginal benefit curve. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 9, here's 1. And this is rockets, is the quantity of the public good, right? And wages are going to be on the vertical axis. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So each one of these people are out here for 1. Let me just undo that last dollar sign. I don't need that. Okay. So the marginal benefit curve for each person was that equation. Marginal benefit equals their wage minus the number of rockets over 9, or 1/9 of a rocket, which is really going to be the slope of our line, right? So this is slope-intercept form, but each person is different. So this is where it's going to get a little weird. So for person 1, they have $1 worth of wage, and they have, if we have 1 rocket, then it would be $1 minus 1/9 equals 8/9. Or a little bit easier is to take this endpoint. So for this person, if we have 9 rockets, then we get 1 minus 9 over 9 equals zippo. All right, so if we were to graph this and I had not my fat finger and you were using graph paper, I'm gonna see how good I do it. It would look like that, right? So we've got a straight line. The slope is 1/9. 1/9 is the slope, and that's for person 1. Now we have 9 people, and so person number 2 is going to have a marginal benefit. So they're going to have $2 minus, with 9 rockets, it's still minus 1. 9 over 9, I'll do it one more time, equals 1. So where this person left off is going to be the endpoint for the person 2. Oops, I lost my, there we go. And then it's going to be the same. So you get the pattern. These should be perfectly straight lines, so you're going to have to bear with me. Finally, for person 9, it's going to be 9 minus 1 equals 8. So if I drew this really carefully, then 8, this person's would end here. Okay, so that is the 9 marginal benefit curves for our 9-person city. Okay, any questions so far? Now, the marginal...
What's coming out your nose, Eddie?
What's that?
So what is coming out your nose, Eddie?
Oh, Eddie's got something coming out his nose?
Yeah, I got a bloody nose a couple minutes ago.
Okay. Oh, yeah, that is cute. All right,
Yeah, I
got
get
it.
those all the time. I feel
All
that.
right. Yeah, good call. Good call. All right. So now the marginal social cost of a rocket is $18. And so at $18, no individual would want to have a rocket, right? So what does the marginal social benefit curve look like? So marginal social benefit curve, it's easy to think about it in terms of 0 rockets, right? So for this equation, if it's 0 rockets, this term disappears because it's 0 divided by 9 is 0. So at 0, we're simply taking 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 1 equals 45. I did work this out ahead of time because wasn't sure where it was all going to go. So if you add up all those numbers, it's 45. So on a different picture, we'd have a marginal benefit curve of 45. And in fact, I think what I'll do, yeah, I am going to attempt to do a little erase job here. Let me do that. Ooh, fun. Look at that. It just kind of disappears like magic. All right, so let me put this line back up here. And so now let me go and call this 45 is the new intercept. And if we had 9 rockets, going back to this point, if we had 9 rockets, then all we're doing is we're subtracting 1 off of each level. So the marginal social benefit of 9 rockets is 8 plus 7 plus 6 plus ... All of that gives us our rocket count for that of 36. So we go up to like 36 up here somewhere. Whoops. And what we're really doing is if we take the 1/9 minus 1/9 minus 1/9, it's actually minus 9/9. So the whole equation would be 45 as our intercept minus 9/9. You guys can kind of prove this to yourself later if you want. But all I did is I took minus 1/9, minus 1/9, minus 1/9, minus 1/9. We're adding them all up and it equals 9/9. Well, this is just 45 minus R. So the new line that comes down here, let's see, I guess this is not being drawn to scale at all. In fact, let me just do a little eraser job so you guys can get a good picture. Let's even erase that. We get 45, right? So it's a slope of 1. That's going to be our marginal social benefit curve. All right, our marginal social cost curve is 18. Each rocket costs 18. So if you solve this equation of 45 minus R equals 18, marginal cost equals marginal benefit, R equals 27. Okay, so that would be the optimal quantity of rockets. That would be RE. All right, well, that's where we'll leave that problem. The kind of the next step would be to look at the majority rule. And would anybody be willing to get enough benefit from 27 rockets? We turn to the median voter, just to kind of foreshadow, we're out of time. So if some of you need to take off, you're welcome to, and you can look at the recording later, but we'll see on Monday. I'll just continue on with a few more comments here. The 5th person's the median. We had 9 people.
Hey,
So
Russ,
the-
what do
Monday.
the problems do for this chapter?
Yes. Yep.
Monday?
Problems are due Monday, yes.
Okay.
Yeah, thank you.
Cool.
So I'll just, yeah, this was the only thing left that I was going to do. So 5th person is the median, right? So now let's look at the 5th person's marginal benefit. The marginal benefit for the 5th person is 5, his wage is 5, minus the number of rockets is 27, and we have 27 divided by 9, which is 3, so the marginal benefit is 2. So that person has a benefit of 2. All right, and so would that person be wanting to do these rockets if we have a head tax? If we have a head tax, they're looking at 18 divided by 2, or I'm sorry, 18 divided by 9. 9 people, $18 of tax is needed. It's going to be $2 worth of tax. So $2 worth of tax, $2 worth of benefit. Is the median person in on this deal? Yes. So the median person would be in on it, and that would work under a majority rule. So then the next step of this problem, by the way, is kind of fun. I think it helps motivate things a little bit. If the lowest person got a pay raise, or not a pay raise, well, it is a pay raise. Their income goes up from 1 to 4, you know, what changes? And so what happens is this intercept would go up by 3. And then you just kind of recalculate the problem. And when you recalculate the problem, some of these numbers are going to change. So the new marginal benefit, let's see, did I work out this problem? I might not have. Yeah, no, I didn't work this one out. But it'd be the same thing. We're going to have the 45 minus 9. So now it's just 48 minus the 18. So that's going to bump us up by 3 over here. So 48 minus 18 gives us 30. And at 30 rockets, would that make a difference for our median person? Because that's the only person we really have to focus in on. This person is still the median. But what changes now is that instead of it being 5 minus 27 divided by 9, it's going to be 30. So 30 divided by 9, and I didn't work this out ahead of time, so let me, 30 divided by 3 1/3, good. So we got 5 minus 3 1/3 gives us 1 2/3. The tax is going to be 30 divided by 9, which is going to be greater than 2, right? So we've got 30 divided by wait a second, I screwed that up, sorry. No, that's still 18 divided by 9. Sorry, it's 2. So yeah, that gives us our marginal cost is still going to be 2 because it's $18 divided by 9 is 2. And so now the cost is higher than the benefit. And so we are not going to pass it with majority rule. The median voter is going to say, nope, that doesn't work for me. And the vote's not going to pass, and we're not going to get the optimal level of rockets. Okay, well, that was a mouthful. Any questions on this problem that I can clarify for you before we close for today?
Who's the median voter? The 30th dude?
The 5th person was the median. So with 9 people, there's 4 people on each side of 5. The 5th person, there's 4 on each side.
Where do you get the 30 from then?
The 30 came when we recalculated this. So the 30 is the optimal number of rockets when, this was part C of the problem, when the lowest income person got a bump in pay up to 4, then that was the median. I'm sorry, that's what happened to the social benefit curve. It shifted out, which then increased the efficient level of rockets to 30. All right, anything else? There's a lot to swallow in that problem, but you guys will kind of walk it through as you kind of work through your problems. Looks like a good place to close for today. I'll stay on the line if anybody else has any further questions. Otherwise, we'll see you Monday.